Hey everyone, and welcome to this explainer. I am absolutely thrilled to have you here today. Look, if you have ever found yourself staring at your screen, just literally pulling your hair out over a JavaScript bug that makes zero logical sense, you are in exactly the right place. Today, we are diving deep into a really critical 9-year evolutionary period that totally transformed JavaScript from this quirky, rush little script into the modern powerhouse we use today. We're going to distill those 9 years of evolution into one definitive guide to permanently fix your core logic bugs. We've got a lot of ground to cover, so grab your focus and let's transform how you write code.
It's kind of a wild question to think about, isn't it? If you've spent any time working with JavaScript, you already know it has some deeply confusing quirks. But honestly, those quirks make perfect sense when you realize how this language was actually born. It was rushed, like incredibly rushed. JavaScript powers almost everything you see online right now, yet its foundational DNA was stitched together in basically a fortnight. Understanding that chaotic origin is the absolute key to unlocking why JavaScript behaves the way it does, and more importantly, how you can actually master it.
So here is our roadmap for today. We'll start with the accidental language, then move into the evolution of variables, scope and execution, the weirdness of coercion, mastering modern functions, and finally, arrays, objects, and chaining.
Let's kick things off with part 1, the accidental language, from Mocha to ECMS script.
To truly grasp modern JavaScript, we really have to travel back and look at its totally chaotic creation story. Back in May of 1995, Brendan Eich, who was working at Netscape, was tasked with creating a language to bring static web pages to life. And get this, he did it in a 15-day sprint. Originally, he called it Mocha, but by December of that year, Java was the massive, unstoppable hype in the tech world. So, in what was purely a brilliant marketing move, they renamed it JavaScript to ride that wave. And yeah, it has absolutely nothing to do with Java. Because it was built in just 15 days, it had massive loopholes. It wasn't until the community completely revolutionized the language with the ES6 update in June 2015 that those glaring early problems were finally fixed, capping off the most critical 9-year evolutionary span in the language's history.
That brings us to part 2, the evolution of variables, var versus let and const.
To really understand our first major evolution of how we store data in memory, I want you to think of variables exactly like an ATM. When you slide your card in, that ATM has to remember exactly who you are, what your balance is, and what you're doing until that transaction is completely over. If it forgets any of that halfway through, the whole system breaks. Well, your code needs memory to track state in the exact same way, whether that's keeping a score in a video game or holding user data on a dashboard.
But here's the thing. How we actually create that memory went through a huge evolution. The old ES5 way using var is buggy, it's outdated, and frankly, it's a bit of a nightmare. It attaches itself globally to the window object, and it's only function scoped. That means it literally leaks out of basic blocks, like if statements. Plus, it lets you accidentally redeclare the exact same variable without even throwing an error. That's a total recipe for disaster. But then we got the modern ES6 way, let and const. These are secure, they're block-scoped, and they will strictly throw an error if you try to redeclare them. We want those early errors, guys. They protect our code. So do yourself a favor and just drop var completely.
So the crucial point here is just knowing when to use let versus const. They are both block-scoped, right? But while let is reassignable, which makes it perfect for something like a player's score that changes from 0 to 10 to 50, const is strictly locked down. Think of const like a concrete foundation. Once you pour it, you can't just casually swap it out. You want to keep your foundation intact by defaulting to const for everything, and only reach for let when you know for a fact that the value absolutely has to change.
All right, moving on to section 3, scope and execution. Where does your code actually live?
So we're shifting away from just typing syntax now, and we're diving into the invisible world of how the JavaScript engine actually reads your code. We've got to talk about hoisting. This is easily one of the most notoriously confusing quirks in all of JS. Hoisting is the exact reason why sometimes you can run a function or use a variable on line 1 even if you didn't actually write it out until line 10. I know, it feels like complete magic, but it's actually a very rigid mechanical process that's happening right behind the scenes.
See, when the JavaScript engine reads your code, it doesn't just read it top to bottom and run it immediately. It actually does a prep phase first. In step 1, it literally splits your variable into 2 distinct parts, the declaration and the initialization. Then in step 2, it pulls just the declaration part all the way up to the very top of the scope. Finally, in step 3, the initialization, which is the part where you actually assign the value, stays exactly on the line where you originally typed it. If you try to access it before that line, you're going to get undefined with var or hard crashing error with let and const.
Okay, part 4. The weirdness of coercion when math breaks. Seriously, if you've ever felt like JavaScript is just actively trolling you, take a look at this classic mind-bending glitch. You have a string of 5 and a number 1. You add them together and JavaScript tells you it's 51. But if you take a string of 5 and subtract a number 1, JavaScript says 4. This right here, this is why beginners pull their hair out. How on earth can the math just change its mind based on the symbol?
Well, the answer is a quirky little concept called type coercion. JavaScript is a dynamically typed language, meaning it forcefully coerces or converts types behind the scenes to try and make things work. The plus sign in programming actually does 2 jobs. It does math, sure, but it also glues strings together. Because there's a string involved here, JavaScript assumes you just want to glue them, creating the string 51. But the minus sign, it only has one job, subtraction. So JavaScript is forced to turn the string 5 into a number, subtracts the 1, and spits out 4. It's not magic, it's just a really stubborn engine following strict rules.
Now, because of this coercion, JavaScript views every single value in the entire world as either truthy or falsy. But here's the trick. You don't need to memorize what is truthy. You only need to memorize these exactly 6 strict falsy values: the number 0, an empty string, null, undefined, not a number, and the legacy object document.all. If you put any of those 6 things inside an if statement, they automatically coerce to false. Literally anything else in the entire language, it safely defaults to truthy.
Section 5. Mastering Modern Functions, First-Class Citizens. So let's shift gears to the core logic blocks that let you decide exactly when and how a piece of code should execute. In JavaScript, functions are treated as first-class citizens, and honestly, this is an absolute superpower. It basically means functions aren't just these rigid blocks of code. They are treated exactly like regular variables. You can save a function into a variable, you can pass a function as an argument into another function, and you can even return a function from a function. This exact flexibility is what allows modern, modular JavaScript to even exist.
But, just like our variables, functions evolved dramatically during that 9-year span. Old-school regular functions use the function keyword, they get automatically hoisted, and crucially, they create their very own this context. Meanwhile, modern ES6 fat arrow functions use that super clean arrow syntax, they are not hoisted when you store them in variables, and this is the real game changer for complex apps. They actually inherit the this context from their surroundings. That perfectly fixes those annoying object context bugs we used to deal with all the time.
Finally, Section 6, Arrays, Objects, and Chaining, Handling Data.
Okay, before we start manipulating our data, I have to give you a massive warning about how JavaScript copies things. Primitives, so that's your numbers, strings, and booleans, they are copied by value. That means you get a totally fresh, safe copy. But reference types, which include arrays, objects, and functions, are copied by reference. If you try to copy an array using just an equal sign, you aren't actually making a new array, you are just pointing back to the original one. So if you modify that copy, you are secretly mutating your original data. You absolutely must use the spread operator to create true independent copies. Otherwise, you're looking at silent data corruption. Once your data is actually secure, you're going to need to iterate over it. Do yourself a favor and forget those clunky old-school for loops. Modern ES6 gave us these absolutely beautiful functional array methods. You use for each when you just want to loop and do an action. Use map when you want to take an array and return a brand new, mathematically modified array. Use filter to just keep the elements that pass a specific test, and use reduce to condense a massive array down into one single value, like a total sum. This right here is how professional code is written today. Oh, and when you're pulling all that data from a back end, you are going to love this modern trick, optional chaining. See those question marks? Instead of writing out this massive, ugly block of if statements to check if the user exists, and then if the profile exists just to get an email, you just chain question marks. It's brilliantly designed to gracefully stop your code from crashing. If profile is missing, it just returns undefined instead of throwing a fatal error that takes down your whole app. And there you have it. You have just absorbed the absolute core of JavaScript's incredible 9-year evolution. We went from a chaotic, rushed origin story all the way to modern, secure ES6 paradigms. You now understand variables, the magic of hoisting, the sheer madness of type coercion, first-class functions, and how to safely handle your data. Those logic bugs that used to haunt your dreams, they are totally solvable now, all because you actually understand how the language grew up over that critical time frame. So here's the real question. Are you ready to open up your code editor and finally write JavaScript that works for you and not against you? Dive in, start coding, and let's put all this knowledge to work. Thanks for hanging out with me on this explainer, and I'll catch you in the next one.